Okay, so this is the information you need to do so that you can perform the fluorescence lab. I'm going to show you how to use the software here and the fluorimeter, and I think that some of this stuff will already be familiar. Well, you haven't used the spectrophotometer, so this is probably the first time you've seen this type of software. All right, the spectrophotometer on-off button is on this left side over here, and you can always tell that it's on because you can hear this, right, that noise, like an insect or something making, like grasshopper or something. So that noise is the lamp arcing. All right, that's the fluorescence lamp. So it needs to be making that noise. It'll shut off after a while, and you can move the mouse and it'll turn back on again. The software itself is right here. Okay, you can see that okay from there. So that's the software. This is what it opens up. Okay, we have a variety of different things we can do. This is where our samples are going to go. This doesn't stay up for whatever reason. Some days it does, some days it doesn't, but we have a handy dandy little stopper there. Okay, so that should be around. In this drawer, we have these 96 well plates. All right, you're just going to take one of the 96 well plates, and we can slide it into this little area right here. Okay, this little thing right here, it puts tension on the corner right there and holds it into place. So if I just slide it in like that, then this will push up against that thing right there. This is the two wires coming in here. Oops, I forgot to connect these up. This is two wires coming in here. One is the light source and one is the detector. Now I need to plug these in really quick. If this front apparatus is not on, you'll need to, I mean, it'll be on for this semester, but if in the future you need to use it for whatever reason it's not on, you'll have to come and get me to put it on. It's very self-explanatory. There's just 3 screws, but you usually need 2 people so you don't drop anything and break it. You just put it on, but I gotta make sure I tighten out these things. Did you have a question?
No. Well, I need some of those strings.
Do you know where they're at?
I know. And it's all
There's some in 137 in a box.
Okay. Still makes sense.
Okay, we're all set. So, light source coming in, detector looking at it. All right, so this one isn't really at 90 degrees. It kind of is, but not quite, I don't think. But it still works, right? It doesn't need to be 90 degrees. In class, we describe it as 90 degrees just to emphasize that it's not in line with the light source like absorbances. All right, so I'll leave this open so you can see what happens here. But under applications, we have well plate reader. So we click on well plate reader, and it brings up this window. And then the well plate reader starts moving around. And whoops, what happened there? Application well plate reader. Let's try it again. Well, it doesn't look like it's happy, so I'm going to close it and try to restart the software.
That'll all get edited out.
What's that?
That'll all get edited out.
Hopefully. My video editing is horrible right now. I don't know, the new computer doesn't like it. So, we open the well plate reader here, and we can set up the plate, we can set up the parameters. Under the tab for set up the plate, if you just right click on any one of these locations, it'll move to that location, and right over here on the right, it'll actually tell you the measurement for its fluorescence. Okay, it's taking a little bit of time because it needs to set it for the first time. But there you have your intensity, 134.635. Okay, so if you right click anywhere, for example, if I right click on the bottom right corner, then it moves to the bottom right corner. And this is good to do initially before you start to make sure that it's lined up. All right. If it looks like it's not lined up, then you come in here to align, and then you can choose to click on the top left corner and the bottom right corner. So if I click on there, and then I can use my arrow buttons not that arrow button, sorry. Whoops. This arrow button right here. And I can align it, and it looks like it needs to be just a little bit to the left. So now it's lined up nice and perfect with that bottom corner. Now I line it with, oops, I click this one here. I line it with the top left corner. And again, make sure that it needs to go to the left a little bit, maybe like 3 clicks. Okay, looks good. And if I need to go up or down, I can do that as well. But I think it's okay. So we have it aligned. I say okay. It offers to save it somewhere. I can save it as whatever. All right. So again, in this mode, you click on a cell and it will move to that cell. If you right click on the cell, it'll move to that cell and it'll look for the fluorescent value for that cell. Okay? Now, what it's doing is it's, again, shining light in, and we're monitoring how much light is fluoresced at about 90 degrees. At the, what light is it shining in though? That's where we tell what light to shine in here at the setup parameters. And what we do is, first of all, we only want one wavelength. So I'm going to delete the wavelength program and just have one wavelength program. Excitation, that's the wavelength of light that goes in. Emission is the wavelength of light that you're measuring on the other side. So excitation, and in your paper for your specific protein, there will be the information, the excitation wavelength for the protein and the emission wavelength. And you put those values in here, excitation and emission, and then you also can adjust the slit width. All right. So here we have the slit width of the excitation light. So the light is coming and hitting this slit, and if you open it wider, then more light will come in. So if I open up this light to, what is the, I don't know what the maximum is here. So 15 is the maximum. So I set it up to 15. The emission slit probably 15 as well. 20. So I'll set it to 20. Okay? And then I'll go back here and I'll right click on that one. And now my number is what? About 314 still. So there's nothing in there, so that's why we're not getting any value. But it's possible that if these slits, excitation and emission slits, are too high of a number, then your value will be 999, and that means maxed out. So you need to make sure your values are not maxed out, because obviously you need to be able to watch a change. If your protein fluorescence changes as you denature it and goes up, then you need to make sure you start about 200 so that you have plenty of room to go up to maybe 300 or 400. Don't start at 850 and then go up off the charts and not be able to determine the degree of when it actually unfolds. All right, so if I put the samples that I want to run, let's say I choose to put them in B, we said we were going to have 10 samples. I use the left button, not the right button. Let's see. How do I, oh, here it is, erase the plate. First one, second one, third one, fourth one, fifth, sixth, 8, 9, 10. So I can tell it where I have my samples. So if I put them in B 1 through 10, and then I'll have the second experiment, which I include my excipient to help prevent the denaturing. Now I have those ones identified, and now I can, as long as my start parameters are correct, I can just go over here and I can push the go button, and when I click that, it's going to go and collect those samples automatically. All right, so it's going through, it's collecting all the samples, and then when I'm done, all I just have to do is jot all these down in my notebook, and hopefully, if we have the denaturing occurring like we think, then we're going to see some sort of change in those numbers. All right. All right, I think that's about all you need to know. And then you're going to plot this change, these values, the fluorescent values versus the concentration of denaturant, like urea or guanidinium hydrochloride. You're going to want to get 2 curves, and hopefully whatever excipient you have chosen allows your curve to shift slightly so that you can identify how much. Uh-oh, what happened there? Oh, it's running twice for some reason. Why is it running twice? Let's stop it. Read time for each well. number of measurement cycles. I don't think we want to do it 50 times, just one time. So I think it was planning on doing it 50 times. Let's verify that this works.
Is that just for consistency of data?
What's
If
that?
you wanted to run the same plate 50 times?
Yeah, or kinetics, like it's going to change over time.
Mm.
All right, so there's your numbers that you can take home. All right, when you're done, you want to make sure you don't throw this away. These can be washed out and then reused. All right, and this is where we keep them. We want to make sure it's not terribly important because this lamp again will turn off when it's done. But if you keep the fluorimeter off, then it will increase its lifetime. All right, great.